Welcome back to Java Internal's Crashcasts. I'm Sheila, and today we're diving into the future interface, a crucial component of Java's concurrency toolkit. We're currently in the fundamentals of concurrency season, exploring the chapter on futures and callables. Victor, are you ready to unravel the mysteries of the future?
Absolutely, Sheila. I'm excited to discuss this powerful tool that helps us handle tasks that take a while to complete in Java. Before we start, listeners should be familiar with basic Java concepts and have a general understanding of how computers can do multiple things at once.
Great point, Victor. Now, let's kick things off with a quiz question for our listeners. Here's a tricky one. True or false, a future always represents a completed task. Think about it, and we'll reveal the answer at the end of the episode. Victor, any thoughts on this question without giving away the answer?
That's an excellent question, Sheila. It really makes you think about how Java handles long-running tasks. I'm sure our listeners will find it intriguing, and it touches on a common misunderstanding about futures. Let's keep everyone in suspense and dive into our topic.
All right, let's start with the basics. Victor, can you give us a simple definition of the future interface?
Certainly. The future interface represents the result of a task that will be completed. Well, in the future, it's like a promise of a value that will be available at some point. Imagine ordering food at a restaurant. The receipt you get is like a future. It doesn't contain your meal yet, but it represents the promise of your order being completed eventually.
That's a great analogy. So, why do we need futures in Java? What problem do they solve?
Futures address the challenge of handling tasks that take a long time without making your program freeze up. They allow us to start a task, continue doing other work, and then get the result when it's ready. This is particularly useful in scenarios where you have time-consuming operations, like searching a large database or downloading a file, and you don't want your application to stop responding while waiting for the results.
I see. So, what are the key methods we should know about when working with futures?
There are several important methods, but let's focus on three main ones. 1. Get. This method retrieves the result of the task. It's like waiting at the restaurant until your order is ready. 2. isDone. This tells you if the task has finished, whether it was successful or not. 3. Cancel. This tries to stop the task if it's still running, like cancelling your order at the restaurant.
Interesting. You mentioned that get is like waiting at the restaurant. Can you explain the difference between waiting and checking occasionally in the context of futures?
Of course. Waiting, which is what happens when you use get, is like sitting at your table and not doing anything else until your food arrives. This can be necessary sometimes, but it might not be the best use of your time. On the other hand, checking occasionally, which you can do with isDone, is like continuing your conversation with friends and just glancing at the kitchen door now and then. This allows you to do other things while you wait for your task to complete.
That makes sense. Now, I've heard that futures are often used with something called an executor service. How do these two concepts relate?
Great question. Think of executor service as the kitchen in our restaurant analogy. When you submit an order or a task to the kitchen, executor service, you get a receipt, future, in return. This receipt represents your pending order, allowing you to check its status or get the result when it's done, without having to constantly ask the chefs directly.
I see. So, what about when things go wrong? How do futures handle errors that might occur during the task?
Futures are prepared for both success and failure. If something goes wrong during the task, like if the chef accidentally drops your order, the future will keep track of that. When you try to get the result, it will let you know about the problem, allowing you to handle it appropriately, maybe by placing a new order or choosing a different dish.
That's really helpful. Can you give us an example of how futures might be used in a real-world scenario?
Certainly. Imagine you're building a website that needs to gather information from several different sources to create a page. Instead of waiting for each source to respond one at a time, you could ask for all the information at once, getting a future for each request. You can then check which responses have come back and use them as they become available. This can make your website much faster and more responsive.
That's a great example, Victor. Now, are there any common mistakes or best practices we should be aware of when working with futures?
Absolutely. One common mistake is waiting indefinitely for a task to complete, which can make your program unresponsive. It's generally a good idea to set a time limit when waiting for a feature to complete. Another best practice is to avoid constantly checking if a feature is done. If you find yourself doing this, there might be better tools for the job, like Completable Future, which we'll discuss in a future episode. It provides more advanced ways of working with asynchronous tasks.
Those are great tips, Victor. Now I think it's time to reveal the answer to our quiz question. The statement was, a future always represents a completed task. Victor, would you like to give us the answer?
Of course, the answer is false. A future represents a task that will complete at some point in the future, but when you first get a future, the task it represents is typically still in progress. That's why we have methods like isDone to check if the task has finished.
Excellent explanation, Victor. To wrap up, let's summarize the key points we've covered about the future interface. 1. Futures represent the result of tasks that take time to complete. 2. They provide methods like get, isDone, and cancel to interact with the task. 3. Futures work closely with Executor Service for managing tasks. 4. They handle both successful results and errors. 5. Futures are useful for improving application performance by allowing your program to do other things while waiting for long tasks to complete. In our next episode, we'll be diving into the callable interface, which pairs nicely with futures for creating these time-consuming tasks. Don't forget to subscribe to Java Internal's Crashcasts and leave us a rating if you're enjoying the series. Thanks for listening.